When explaining how an electrical circuit works, it is helpful to compare it to a hydraulic and pneumatic circuits, which work basically the same way. To break down the basics of electrical circuits, we talk about the three sets of three. The first set of three is voltage, amperage, and resistance. These terms are similar to the terms used in a pneumatic circuit. Voltage, or volts, corresponds to pressure, psi. Amperage, or amps, corresponds to flow, or CFM. And resistance, or ohms, corresponds to pressure drop, psi, or flow restriction. By referring to the pneumatic circuit shown here, we can begin to understand how an electrical circuit works. This pneumatic circuit is actually a tire. Inside this tire, we have high pressure of 30 psi. High pressure seeks low pressure. The good tire at the top is not going to let the 30 psi inside the tire escape to the 0 psi outside of the tire. That's infinite resistance. The not-so-good tire in the middle has developed a pinhole leak. The resistance to the flow of the air from the inside to the outside of this tire is something less than infinite. There may be a flow of about 1 CFM out of the tire. The bad tire at the bottom has a nail hole, which is bigger, resulting in less resistance to airflow. There may be a flow of about 10 CFM out of the tire. High pressure seeks low pressure. We can equate the pressure, psi, inside the tire to voltage, or volts. We can equate the size of the hole, diameter, in the tire to resistance, or ohms. We can equate the airflow, CFM, to amperage, or amps. The components of these circuits are in series with each other in their respective circuits. The performance of any component will affect the entire circuit. The electrical series circuit looks much like the hydraulic series circuits in the previous slides. In a good working hydraulic circuit, the pressures were all 100 psi feeding the motor. The electrical voltage or pressure will be 120 volts feeding the solenoid coil. On the return side of the solenoid coil load, the voltage shall be 0 volts in a good working circuit. Electrical pressure meters, or voltmeters, use two electrical probes to read voltages. The voltmeter reads voltage differences, or in other words, electrical pressure drop. A pressure gauge actually has two probes as well and measures pressure drop. The pressure in the pipe is being compared to the pressure outside the pipe. The voltmeter compares voltage drops in one part of the circuit with another part of the circuit. Our testing procedure shall standardize on comparing voltages in various parts of the circuit to the return side of the power supply. The return side is commonly known as ground in an AC circuit or common in a DC circuit. The meter reads 120 volts AC at terminal 1 and 0 volts AC at terminal 2. The resistance across a closed switch and some wire should be 0 ohms. The fact that the voltage drop across a piece of wire and a supposedly closed switch is as high as the power supply indicates infinite resistance. Somewhere between these 2 points is either a broken or disconnected wire or a bad switch. Probing on both sides of the switch will determine whether a wire or the switch is bad. Rule 5. Wire and ducts and pipe should have near 0 pressure drop. Pressure drop equates to resistance to flow in a circuit. High pressure drop equals high resistance to flow. Low pressure drop equals low resistance to flow. The operator turns on switch 1 and switch 2. The solenoid energizes. The starter does not energize. The light does not illuminate. The solenoid is energized, meaning everything in that series circuit between terminals 1 and 2 and between terminals 7 and 8 is complete and working. Everything in parallel with terminal 2 and terminal 7 is not working. Both the starter coil and the lamp, or the respective branch circuit wiring, going bad at the same time is very unlikely. Therefore, checking either of these branch circuits at this time is a wasted check. the part of the circuit that is common to both branches, but not part of the solenoid coil series circuit, should be suspected. That leaves the wire and switch between terminals 2 and 3 and the wire between terminals 6 and 7. Checking at terminal 2 is a waste of time. Terminal 2 will have 120 volts AC on it simply because terminal 2 is part of a working circuit. Terminal 3 and both sides of switch 2 should be checked for 120 volts since they are common to both circuits. By process of elimination, the wire between terminals 6 and 7 is the only thing left. Checking with the voltmeter, terminal 6 reads 120 volts AC, and terminal 7 reads the expected 0 volts. A high voltage drop across a wire indicates a break or bad connection. Part of this module teaches you about components, some circuits, how to use the voltmeter in low voltage applications, and how to use the ohm meter in 0 voltage applications. You will learn about fixed and variable resistors and the different resistances of various components. You will also learn about switches, electromagnetically operated switches, process-operated switches, and how they logically do work for us. High voltage applications are discussed in the second part of this module.